on the YouTube side.
Hey, gentlemen, welcome again. It's time for the special weekly Monday morning vlog podcast, 11 to noon every day, every week anyway, for the Santa Barbara Astronomical Unit. We call it the SBAU Astro Hour. On behalf of Santa Barbara, California's longtime astrophysics and telescope club, based right there at the Santa Barbara Museum of Natural History up in Mission Canyon, where we meet on the first Friday of the month, usually general meetings, 7:30 p.m. Host a very popular outdoor star party every month on the second Saturday, starting at dark. And doggone, if you are interested in astronomy, come and join us, because we check out on SBAU.org all the things we do. We watch live here on Monday mornings, our little YouTube excursions. We're up to number 173 this week, about 3.5 years into the Astro Hour. I'm your host, Ron Heron. I'll introduce you to the rest of the guys in a minute here. Ladies and gentlemen, these are our cutting-edge cosmology topics we're going to consider covering. Ready for summer solstice? Got a full strawberry moon ahead. It's waxing gibbous right now. 4 stars. Listen to this. 4 stars in Delphinus or Delphinus. I'm not sure how you pronounce
Delphinus.
the dolphin. Yeah, whatever. It's called Job's Coffin. The 4, they include, well, it's an asterism. We're going to check out a lot of Messier objects up in Ursa Major, including the Surfboard Galaxy. An equilateral triangle in the eastern sky features Vega and Lyrae stars, including a double-double. And we're going to take a big, long, hard, close look at solstice, how it works, and the different modern time systems of time zones and time one. Let's meet the gang. President, Starship Commander Jerry Wilson, married to lovely Pat Forgy. Hi, Jerry. Thank you.
Good morning.
You're in control. And my radio voice is in the damn shop. It's this damn loaner they gave me. It's never any good. Chuck McPartland is our outreach coordinator. He's also married to Pat McPartland, who is our merchandise manager as well as treasurer. And there's a lot of outreach coming your way. We'll hear about that in a few minutes. Also on screen, on the bottom left for me anyway, is Bruce Murdoch, who's married to he's married to Bonnie, not Maureen. You haven't been seeing Maureen, have you? Never mind. We're not going to go there. Anyway, Bruce is Theater Organ Society president for Santa Barbara. Maybe you can give us an update sometime. Tom Whittemore is retired from Westmont. Tom is married to Maureen. And doggone, there is Tim Crawford, who's married to Karen.
Hey,
expert on telescopes. So we start the week, every week, with a little silliness, because the president has forwarded all these cartoons to us, and they're silly, and they're mostly based on science. And I got a dozen from you, so I doubt you'll hit all 12 of them, but let's see what's on the screen and start the day with some levity here, ladies and gentlemen. Captain,
Yeah.
Beam them up, one at a time. Here we go.
Yeah, here we go.
I promise we do this. We have a bevy of these over the years. Huge archives. Would you believe I scream in the morning to get my voice up and people bang on my door? Are you all right in there? I used to do it walking to work at 5 in the morning, but people's lights would go on in the dark. Okay, we are having problems, Houston.
We are. I don't have, it's not giving me the
Okay, but we are on YouTube. You can watch us on YouTube, everybody, and ask questions. And I guess the man turning away there, Tim, will be here. Here we go. Silly stuff.
Can you see this one?
We got them all lined up. There's what, 9 of them? No, there's
each one of them though.
11.
Yeah. Okay, that's not what I intended.
No, we need to separate them.
My machine got updated overnight. This may be trouble.
Uh-oh.
One of those updates comes in and screws everything up.
Yeah.
Oh, that scares. That's been a long time AI at my house.
What is that, MicroSwift?
Yeah. You know, when the screen goes light blue and it says, "Don't turn off your computer," I just sit back.
Blue screen of death.
Yeah. Well, Maybe we can. Here we go.
This is gonna work, Jerry. Yeah,
There we go.
kind of.
All right, we take you to the bookstore, one of the closed, either Barnes and Noble or Book, or what was the other one? Borders. Please note, ladies and gentlemen, the post-apocalyptical fiction section has now been moved to current affairs. It's all happening now. Yeah, that's true. That's rather scary. Okay, beam this up a little. All right, two gentlemen, two astronauts are on the moon looking back at the beautiful Earth. One says, you know, what a beautiful view. The other guy says, yeah, from up here, it's obvious there's no borders, nothing. It's all one people down there. Just a bunch of losers who have never been to the moon. Yeah.
like that one.
Okay, here's a father and son checking out a bookworm. And he says, look, Dad, it's a nerd. Dad says, you know what we do with nerds, don't you, right? Yeah, Dad. We learn from them. And there's the bookworm going, Venus rotates in the opposite direction to most other planets. Oh, my God, that's so cool. Welcome to the Big Bang.
There was a cute cartoon that was a Calvin and Hobbes, where Calvin is being bullied by the school bully. And he said, you're a nerd. And Calvin came back with, I prefer the phrase smarter than you.
Bookworm is good, too.
Yeah.
All right, here's a relocated couple to another planet. They've colonized the moon surface and they're sitting out there on their porch. Can you hear me? Uh-oh, we're on the phone.
Audio off on my.
You're gonna have to mute yourself there,
You gotta mute, Bruce.
Bruce. Bruce, mute.
He
Thank
is.
you. Okay, husband and wife sitting on their porch on the moon, colonizing the Earth, honey. The Earth-like planet here is a chance for us humans to start over without ruining the place like we did Earth this time. He goes, yeah, I know, honey. What idiots we were, as he tosses an empty beer can out onto the surface of the moon. Here's what can happen to a handsome young scientist in the late 1800s. It's what quantum physics does to a man like Max Planck, shown in two different versions. Something similar happened to Marie Curie involving radium, I understand.
That was more deadly. Yeah, she died of
She died of cancer.
All right, here's a look at the future, one of those comparing us to AI, and guess who's sitting, wandering, and reading books and coloring and having fun while the rest of us walk by? The robots. That's how it's going to look. I'm not sure how I'm going to get through. And here's different views of stars. For some reason, five arms. This is a starfish. This is a star fruit. Both of them named for their star shape. And here is what a star actually looks like. A big round yellow circle, or white, but actually it's the points. What do they call the points that show up in your telescope viewer?
Diffraction spikes.
But you'll never get 5 though, will you? It's an even number, either 4 or 6.
Yes.
Okay. On the stage at the scientific symposium, the man announces today's guest speaker will discuss recent advancements in string theory. And there it is. That's Chuck's cat. About to roll out on stage a large yarn ball. String theory. And here we go, a tour of a research facility. And the scientist, the host opens the door and says to his guest, and this room when we reserve for competing theories. And they're beating the snot out of each other. That happens. That's the way it is. Or they can arm wrestle.
Yeah.
These are good. I don't know where you get them. Here's Linus yelling at the world, trust the science. It's the most anti-science statement ever. Questioning science is how you do science. Yeah, right on. I guess that's Linus, isn't it? Is he the one with the blanket?
Yes.
Yeah.
All right, here's Mr. Spock with his pointed ears going, you know, roses are red, roses are blue, depending on the velocity relative to you.
I didn't see that one.
Yeah, I came up with another one. Roses are infrared, violets are ultraviolet, and there's no rhyme for any of that. But
yeah, you're reaching a little bit there.
Yeah. Okay, we got some good stuff this week. Time zones and equators. It's solstice, but it involves the equator going, south or north? It's north, isn't it? Never mind. Here's Dawn looking east. Mr. President, take over.
Oh, this is just a shot later this week, 30 minutes before sunrise, looking east. Mars and Jupiter are the prominent planets in what used to be that lineup of planets, along with the Pleiades and the Bull, Taurus, without Eberron coming up in the east. These will be in the sky in the evening in the fall. The constellation will, the planets will be different.
How in the world did you get this picture? Do you have time travel?
This is from Sky and Telescope.
Yeah,
Oh, okay.
down here, 2024, yeah.
Projecting. All right, 30 minutes before sunrise. That was not in the talking points. Okay.
Yeah, there's a couple things you'll find. There are about 5 things that are not in the talking points.
Ah,
I added them later. This one is.
I'm glad you said that.
What's that?
I'm glad you said that because I was thinking, uh-oh, what did I miss?
June 17, that's tomorrow. Oh, it's today.
Hey.
9 o'clock tonight. This is the waxing gibbous phase of the moon you see here. Mar Imbrium, which we'll see shortly in a blow-up picture that's not in your talking points. And these seas are one of the most prominent features here. And these are actually large impacts. Mar Crisium, Spranum, Mar Serenetis. And they're all happen to be on this side of the moon, which suggests, but doesn't prove, that they impacted as a collection. Otherwise, they would have been distributed randomly around the moon.
So, Jerry, may I make a point here?
Yes, please do.
Yeah, so last night I did a lot of looking at the moon with the binoculars in the sky window. And one of my favorite craters, Gassendi over on the left, lower center, was just starting to fill up with light. It was really beautiful. It's a real famous crater for like a 9-day-old moon, just roughly, maybe 9 or 10. And what you see is on the left side of Gassendi, that ridge there lights up like a little crescent, okay? And if you put a telescope on it, I just had 8-power binoculars, but if you put a telescope on it, you see that wonderful crater on top of the rim of that major crater in Gassendi. So absolutely beautiful. And I take it, Chuck, that those red lines there are probably the moon days, huh? Probably.
It's latitude and longitude. It looks
Oh,
like.
it's just latitude and longitude. Okay, I was going to say last night, see that red line going through there, up and down. That's kind of where the Terminator was last night. And
here,
yeah, that one. And the whole left side of Gassendi looked like a little crescent. Looked like a little crescent. It was really pretty. It's a favorite for me. And Copernicus came in just astounding. Even in 8-power binoculars, I couldn't see the structure on that central peak, but I could see the peak. It was a super night last night. So that's my take.
We did have some good weather here recently, even down in the lowlands. I can imagine you up on the hillside.
Yeah.
Now, is this 3/4? Is this waxing gibbous 3/4 moon we're looking at?
No.
It's not 3/4. What is this called?
Gibbous.
It's just gibbous. It's probably what, Chuck, 10 days old, something like that, roughly.
Right.
Yeah, probably about that.
Yeah.
So this is
just one other comment, Jerry.
Halfway between first quarter and full.
Yeah. One other comment was, I have Sky 8 here on my machine. And every time you light it up, they tell you something cool about the upcoming night. And it said that there was an occultation of Spica by the moon, but only in Asia. So I took the binoculars and looked over to the west of the moon. By gosh, there was Spica.
Yeah, right close.
Yeah. That's it.
Okay.
Thanks.
So anyway, you see that the moon on the other side, which is not shown here, and this side, it is heavily cratered. These craters happen what used to be called 2 large bombardment effects, but I think it's down to 1 now, where they have one period where there were just a lot of these Ptolemaeus and Alphonsus-sized objects hitting the moon, and that completely covered the moon with these craters. And then later, at a later period, these large impacts hit that caused the mare and broke through the crust of the moon. The moon had cooled enough that the crust was easily breakable, And it did, and it let the lava come out. I guess it's magma inside. And it came through the crust and it filled the depression that was created by the impact. The impactor is still in there apparently, and it's because they're finding things called mass cons, which stands for mass concentrations. And you can probe the interior of the moon by orbiting it and taking careful measurements of your orbital path as you go by. Because when you pass over a mass con, it will distort your orbit a little bit. And from that, you can back out what the distribution of mass is in the moon.
Wow. Wow.
So would it be fair to say, gentlemen, that those big, huge seas, Tranquility and others, the Mares, are nothing more than supersized craters?
Well, they're flat because they filled up.
Yeah.
Wow. And the incoming asteroids were bigger than the ones that just leave the little round circles we see. These would be big craters, thus big rocks.
Where the big chunks hit.
The moon at that time was structured differently. It was mostly still molten inside with a thin crust. And these big impactors smashed through the crust. They're not due to volcanoes spewing lava and flowing out like you see in Eastern California here. There's no, what do they call those cinder cones? There's no associated cinder cone with these, but there is a mass concentration under them. But there are volcanoes on the moon.
Really? Our moon has never been like Io, Jupiter's moon.
Wow.
No, not like that. This is Mare Imbrium close up from a satellite. And these are not volcanoes, these are all impact sites. But this shows the layers of lava that froze in place from these massive flows.
Oh.
Where the stuff was coming up from inside the moon. This is called the Marius Hills on the moon. And this is what dormant volcanoes look like on the moon. Not these features, but these domes. Because the magma would be very different on the moon than here. You won't see any Mount Fuji type structures or any Olympus Mons like on Mars. You won't see those on the moon. So there is this stuff. That's what extinct volcanoes look like on the moon.
Now you wouldn't see them, Jerry, because it's just because of the composition?
Say that again?
You won't see the Olympus Mons type because of the moon composition?
Because of the composition, the hypothetical composition of the magma.
Okay.
It's
too fluid.
Is it still there? Does the moon still have lava inside it or magma, or is it all dried?
I don't know if it has any liquid inside of it. I suspect it might.
But it's way down in the core, if anything.
Yeah. Under pressure, things get hot. And with radioactive elements, there was back in the 1800s, one of the famous thermodynamic theoreticians, whose name escapes me, but he calculated the age of the Earth, and he did a good job mathematically of it. He said that he proposed starting with an Earth-sized ball of magma. And then he calculated how long it would take for that magma in a sphere to cool off and get to the state that he believed we were in now. And he did a good job with that math. His assumptions were wrong, but his math that followed through were right. And the thing he had wrong about the assumption that led him to calculate that the Earth was much younger than it is this was before radioactivity was discovered. And he didn't know that there were radioactive elements in the Earth that generate heat. He didn't. So he was just assuming a thermodynamic thing cooling off.
Yeah. Sounds like Helmholtz.
Put in the radioactive heating, he would have come to the right answer with his math.
I think it was Rutherford, wasn't it? Or
it was Rutherford.
I think so, yeah. I think that's right.
Not Clausius, huh, Chuck?
No, it wasn't Clausius.
Had a similar situation on Mars. There's no lava inside it either.
Yeah, there is.
Oh, there is some in Mars.
Yeah.
Okay. And is that what gives plate tectonics? I know that's an Earth thing, but they say there's no plate tectonics on Mars because of that, isn't it?
It's because it has a unitary crust. It doesn't have oceans and things in between. And
We have two major types of rocks on the Earth. We have the stuff that's on the bottom of the ocean, and then we have granite continents, which is a much lighter rock. And so our continents, our dry land, floats on the heavier rock beneath it. And
Floats on rocks, not on magma.
Well, it's on rocks, but it's under pressure and it's like plastic. It's not, like a liquid lava, but it is plastic. It does yield to pressure and it does flow slowly in convection cells, and that's what gives us our plate tectonics.
Well, I wonder if they can find out, just like water used to be on Mars, maybe they had tectonics once. Maybe it was like that on Mars, but
Well, water provides erosion, but it doesn't provide tectonics.
well, I wasn't comparing them. Okay, we're back to the moon, everybody.
Now, this is a close-up of one of those extinct volcanoes. So it's a lava dome.
Wow.
Okay. Now we're moving on to Delphinus. This is a photograph of Delphinus. It's a very obscure constellation. These four stars form Job's coffin.
For some reason, I'm expecting the Star Wars theme right now to break out.
No. Now, this is it in a planetarium program. So these are those four stars, and it adds this one on it too, which was out of the frame on that picture. That was a photograph. This is a plot from a planetarium program, and it has two globular clusters in it. Not the most spectacular in the sky.
Yeah, 7006 here is a pretty tough cookie.
To find, yeah,
I
visually.
can count on one hand the number of times I pulled that one in.
Okay. And there's galaxies. There's a galaxy here. And there's a number of them all around. And
Wow.
There's a planetary nebula right here at the index finger of this cursor, one just outside the boundaries, and another one in here, still in the boundaries.
Boy, that's a busy field, huh?
Yeah. It's not a common thing to look for. It's a fairly small constellation. So this is, it doesn't matter.
But it does look like a dolphin jumping out of the water.
Vaguely.
It really does,
Well, is there a picture of one on the ceiling of our planetarium when they throw up all the constellations?
yeah, but the image they use is one of those medieval dolphins,
monsters of
looks really weird. Yeah.
Yeah.
It would have been a
Here's
flipper.
a famous landmark star.
Looks like a largemouth bass to me, Chuck.
Rockfish.
So the dumbbell's kind of up and to the left from that?
Well,
No, the dumbbell is off of Sagitta the Arrow.
Yeah.
Oh, okay.
So here's a famous guide star to help you find Delphinus. Along with its two wingman. Anyone? What's this star?
Altair.
Altair.
Wow, that's Altair?
Yeah.
Wow. Oh,
Yeah. And the eagle, Tim.
Yeah.
yeah. I didn't know it was that close to Delphinus.
Yeah, it pretty much comes up due east too. It's pretty easy to find. It's pretty bright.
Huh. Nice.
Now, where is Job's coffin?
Right there.
Just
This
those
little
four. Just those
those-
four.
That's the asterism. That's supposed to represent a coffin.
I think that's pretty wishful thinking.
Yeah.
Okay, well, Job was in the Bible. Did he get
Yes.
killed violently or something? I don't remember the story of Job.
He wasn't the one that was raised from the grave. That was Lazarus.
Oh,
He's what?
Oh, that was not the one that was raised from the dead. That
Oh,
was
That's
Lazarus.
Lazarus.
Yeah. Job's daughters. There's Job's daughters among the Jews.
Job was the one that the Lord kept punishing and punishing and punishing and
Right. There's the book of Job.
experienced personal trauma and disease and everything just to test his faith.
Aha.
Why would he do that?
Okay, but it's going to be hard to see this because of the full moon coming.
Yeah, that's why we're looking way north.
Right.
This stuff is easier to see early this week. We'll get the full moon at the end of this week, or I guess.
Right. And it's also at the end of the Scorpion too, so away from here.
Yeah.
Okay.
So this is looking north, and this is the constellation here of the Big Dipper, Ursa Major. And the objects that I posted around for this are in this area, but not all in the constellation of Ursa Major. So I just picked things up here. There's Cor Caroli. I didn't show a picture of that. But M51, which is also behind me here, in the picture I took. And then there's M63, M94, M106. A lot of Messier stuff here. Of course, he was in Paris or France, so he's going to do a lot of damage to the northern hemisphere. M40, M97, M108, M82, M81.
108 is the surfboard, right? You have a picture of that.
I think so. Yeah, we'll get to it.
Okay.
Now this is a Messier object.
Yeah,
That's the double. No,
No, this isn't the double.
no.
but it is 2 stars. Are they binary?
I don't know.
I think it's just a double, and this is considered sort of a mistake in his catalog, but
Right. Messier was looking for a nebula reported in the area by the Polish astronomer Johannes Hevelius in the 17th century, but he didn't find one. So he cataloged the double star instead. The nebula reported by Hevelius may have been the 12th magnitude barred spiral early type ring galaxy NGC 4290, which may have been visible in large telescopes at the time, but not those Messier used. So there was just a general confusion. So this
What is that? M what, Jerry?
What's that?
41?
This is M40. M40.
Yeah, that's the one that was like Chuck said, the mistake. It's like probably the only one that's.
No, I think there's another one that's a single star.
no, there isn't.
I think this is
Just this one, huh?
This is the only one that's not nebulous in some sense, either a galaxy or.
yeah.
And I hate to bring it up, but maybe it was a comet, and he missed it.
Okay, M40 is a double star, not a double, then they're not orbiting each other.
Right.
Okay, got it.
Yeah, a double would be a quadruple star system.
Well, I wonder why they call it a double.
This is M51, and my poor attempt at M51.
Whirlpool.
But you can see a little of the outlier stars here being flung off. Just pointing at it with my finger doesn't help. The smaller, it's 2 galaxies, just the core of this one is left. Being close to this one, it has flung off a lot of the stars now that they've been slingshotted out into intergalactic space. There's another galaxy in the background there, there, and yes, those are it. Oh, there's a one down here too. Although that might be something in this galaxy, but I think that's a background galaxy too.
I think it is. Looks elliptical.
Yeah, it does to me.
Well, it's hard to understand why would it be thrown off. Why not sucked into that larger one on the right?
Well, I'm sure that all the stuff on this side was, and you can see there's a faint haze going around this way. So these are stars that are adding another arm to the big galaxy.
Wow.
Some of the guys
ravaged.
And just like you get 2 tidal bulges on the Earth from the moon, you also get stars flung out on the opposite side of the other galaxy.
Yeah, good point.
So there's a lot of stars out in what's called intergalactic space that are
they're no longer in a galaxy. That's about a 50-50 possibility for our sun when Andromeda collides with us. I've seen several computer simulations of the view from our sun during and after the interaction, and one of them, our sun gets flung off into space and doesn't end up in either galaxy.
Well, if that were to happen, Mr. President, our night view would be what? Just little blobs of galaxies in the sky?
It would be very dark.
Well, once you've traveled for a long, long time, but otherwise your sky's going to be filled with a really cool view.
Yeah.
I'm confused here. You've already said it, but I'm confused on it. Why do we see the haze around the spiral arms?
This
Stars
one
have gotten thrown out. They're just dim stars.
Yeah.
Huh.
here's dim stars, but then it's a larger collection of them.
I wonder if they call them rogue stars once they're thrown out.
Individual stars, when they see it not in its usual environment, they call that a rogue, whatever, a rogue
Yeah.
planet or a rogue star.
Because there's rogue planets going all over the Milky Way, aren't there?
Yes.
Mhm.
And some paired up giant planets in twos in the Orion Nebula.
Are they called binary planets?
I
good.
don't think that phrase was used, but it doesn't matter what they call them.
Is 51 coming towards us?
I don't know that, but
Uh,
I don't
don't
think
know.
so.
I don't think so, Tim.
Huh. In this image here, I'm kind of seeing these stars that are thrown off, but it almost looks like they're trailing behind 51. And that's just probably, maybe that's just just an optical
Oh.
illusion.
The other galaxy there, the smaller galaxy, is a background object.
Mhm.
Huh.
It not real far away, but it's not at the same plane as we're looking at here.
Yeah.
Yeah.
You mean this galaxy?
So
No,
is
I
it-
mean the interacting one. Yes,
Yeah.
there.
Yeah,
it's
Jerry,
very
I have
interactive.
I have a coffee cup with this on it, by the way, Jerry.
Yeah.
And that's
Oh,
what
yeah.
happens when you add milk.
Yeah, you get Milky Way.
Someday it'll be on one of our SBAU bookmarks.
Yeah,
Maybe.
and Mike Summerlin, I think, took a really nice image of 51.
Some of the guys in the workshop, Tom, are getting. I think 51 is one of them. But they're getting
Yeah.
some amazing results with this new software.
Yeah.
Well, what we're looking at then is a future bigger galaxy. Well, I wonder if it'll stay pinwheel or will it become elliptical and a big fuzzy ball of cotton or what?
I guess we'll just have to wait and see.
Yeah.
Okay, I'm sure it'll happen in our life. All
It'll
right.
definitely disrupt the spiral arms.
Wow.
So that's 64, 63.
Sunflower? Or-
This is Messier. Oops. Oh, that's right. Yeah. This is M63.
Yeah.
This is taken by Adam Block at Mount Lemmon.
Hmm.
Looks a little like a sunflower.
Probably the 60-inch.
He has he could have got the data from anywhere, but he has a 24-inch RC
Oh,
telescope.
24?
at Mount Lemmon.
Okay.
Does it have spiral arms?
Yep.
And
Mhm.
with a lot of dust up here on this part, that's what gives it this, I don't know.
Huh.
There's a nice little edge on spiral over here, way in the background.
Mhm.
They can tell not only how far away these suckers are, but how it compares to our Milky Way. You think it's bigger or smaller than us?
Mm.
We're
Easy to
pretty big,
determine,
so I'm
but I
going to
don't
guess
know.
smaller.
We've gone beyond 100,000 light years, haven't we?
We now think we're 200,000 light years. I guess it all depends where you call the edge because it drifts off diffusely.
But Andromeda is always going to be bigger than us, I'm sure.
Mm-mm.
No, we're about the same size.
Oh, no
Yeah.
kidding.
I've heard estimates of Bruce is exactly right. It depends on how you define the edge. But I've heard definitions that we're up to 1 million light years in diameter.
Oh, wow. It keeps growing.
Yeah.
I thought
But
we were
it's
about
obvious.
300,000. We were about 300 million stars, and Andromeda is 1 billion stars.
Well, a galaxy probably has something akin to our Oort cloud, a galactic Oort.
Yeah.
They have halo stars, yes.
Yeah, big halos. Says Andromeda is coming at us. Are we also going at it then? And I guess we're not sitting here and it's coming to visit us.
They're coming to us relative to us, and we're coming to them with relative to them.
Okay.
Yeah, there are no fiducial marks in the universe, that you can say,
Yeah.
okay, this part is not moving, and then we can talk about, how we go with respect to it. Everything is moving.
Yeah, that's I used to say on the freeway, a wreck, and we're in it.
Yeah.
This is Messier 87.
Mhm.
This is a Hubble Space Telescope image. This is the galactic core shown here is a composite image of visible and infrared radiation in order to resolve the blue jet. This is the galaxy where the core was the black hole, a supermassive black hole at the core. was photographed with a radio or telescope array the first time.
And it's in
straight
Virgo.
down.
It's not up in anywhere
Right.
near.
It's in the region of Ursa Major, but it is in Virgo.
Well,
Yeah.
sort of, I guess.
Yeah.
I mean, it's in the south, so it's
Right.
kind of away.
Yeah. And there's a woman in Texas who saw the jet with the 20-inch, but she's got amazing eyes. The 20-incher.
Wow.
She actually saw the jet.
So this is M87, a giant elliptical.
Mhm.
And I wrote
Yeah.
down, I wonder what this means. I wrote this down from your notes. The first SMBH. What is that?
Supermassive
Supermassive
black hole.
Black
Yeah.
hole.
It's kind of the center of attention, Ron, of the Virgo cluster. And when you get that whole bunch of those galaxies that have Messier numbers, this one really, no pun intended, shines out.
It's the 500-pound gorilla of the cluster.
800-pound gorilla.
Yeah.
Do these jets stop and then start again as the black hole feeds or
Yeah, you can see it's broken. It's not a continuous stream.
okay.
So this is its time history laid out in front of us.
Oh, I see.
Well, what's tossing it out?
The black hole.
Hole at the center.
Black hole. Yeah.
Black holes? I thought they did just the opposite. I'm sorry.
No, when they're feeding too fast for everything to go in, they have these jets coming out of the rotational axis where they throw stuff out. Sometimes at almost the speed of light.
Okay, so the what do they call the discs? Starts with an
Accretion
A.
disk.
What? Accretion. Those are all flat. They're like a plate or a
Yes.
okay, they're never round. Got it. Interesting.
Yeah.
Ah,
Yow.
Now,
Uh-huh.
in this region, also, we have a planetary nebula. So not all the interesting objects up there are galaxies. Most of them are, but you saw we had 2 stars. And now we have a planetary nebula, the white dwarf at the center that threw off all this outer layer in several different eruptions, it appears.
And that's supposed to look like an owl.
It does. There's the 2 eyes.
See the eyes?
There's a
Yeah.
dark spot for the beak.
To M97?
Yeah.
Yeah.
This is yes, M97.
Oh.
you think we could pull that out Friday night, Tom?
Oh, that's tough, Tim. You need an 03 for sure.
That'll come with the Melancam.
Oh, yeah.
Yeah.
Chuck can nail it. Mhm.
Yeah.
Mhm.
I didn't know nebula could be spherical. I thought they were just vast splotches of gas and dust.
They're both
Are there,
things that are not mutually exclusive.
if there were stars in it, would it also be a cluster? Cluster
There are
and
no
a nebula?
stars in this except for the center star.
Oh, okay.
This isn't where stars are being born. This is where a star died.
Mhm.
Blew up, yeah.
And what I didn't realize with planetary nebula is they're usually bipolar, so we could be actually looking kind of right down the tube here.
Yeah, we could.
Yeah, and often when they're bipolar, it's because they have a companion star orbiting the white dwarf that channels the outflow.
Mhm.
Well, I
Look
hope-
at M81 and M82. M82, you're looking edge on. M81, you're looking kind of almost face on.
well, if it's
But those are
bipolar,
galaxies.
wow. Interesting. A bipolar nebula. I wonder if it's getting
Uh-huh.
professional help. Never mind.
100.
So this is a galaxy Messier 100,
That's a beauty.
taken by the European Southern Observatory.
Called the mirror.
Is this the one, the mirror?
That's what it says in your notes.
Okay, that one's the mirror galaxy. I'd never heard that before, but that's what Wikipedia listed it as, so I put it in there.
Yeah.
And you got to remember those names, like the Owl Nebula, the Mirror Nebula, they're just arbitrary things from largely amateurs or they change with time, in vogue, out of vogue. My favorite is the Omega Nebula, which never looked like the Greek letter Omega. It's only half there, so I always called it the 2 Nebula.
Ah,
We call it the Swan also.
And now it's called the Swan Nebula.
Yeah. for the
I'm looking
makeup.
forward to hanging 10 off the surfboard coming up here in a minute.
Boy, I had a great view of the Swan last year out at Bacara. It was an unbelievable night.
Wow.
Just an aside, but
This
I never had a better view.
Would this be the pinwheel 101?
No, somehow the pinwheel, I didn't get that here.
You
Should be.
jumped over it. It went by quickly.
Oh, did it?
Yeah.
Oh, yeah, there it is. Yeah.
Yeah, 101.
Okay.
Oh, no, wait a minute.
That's the surfboard right there.
There,
Yeah.
we were at this one, M100.
Mhm,
Then we went to M101.
mhm.
Which is
This has a
pinwheel.
much more open. Yeah, this is a
Yeah,
beautiful.
that's a spectacular object.
Yeah.
First time I saw that was at Lassen with my 18. It was kind of the maiden voyage for that telescope I built. It's really neat. With
Isn't
your eyes,
this
you
the-
can see the spirals, Tim.
Isn't this the opposite side of Alcade from 51?
Yes.
Yeah.
Okay,
mhm.
yeah.
But it forms like a triangle with the two stars at the end of the handle. It
Mm.
forms
Okay.
an equilateral,
That's right,
nearly
that's right.
equilateral triangle.
That's the way to find it. Yeah.
Oh, I see. Yeah, right there.
Where is, oh, yeah, M101 right
Oh,
there.
yeah, just above, right there. Yeah.
So
That's it.
M51, M101, M63 we've looked at. So we're just working our way down here.
Mhm.
Yeah, I've seen that 101. I've yet to get a really good view of it. It's big.
Yeah.
Yeah, it's big. It's low surface brightness, and it had a supernova in it like a year and a half, 2 years ago.
Yeah.
My star hops to get to these two, I look at these two stars, and then I
Mhm.
go at right angles out there. And then I go to these two stars, I go to the midpoint, and then go right up there.
Mhm.
Wow, that's a good hop, Jerry. Thank you. Yeah, I have a hell of a time finding 51.
Hmm. And all of these were cataloged and discovered before our Revolutionary War, before the Declaration of Independence. It's
Or
just
in
amazing.
that neighborhood.
Yeah, in that neighborhood.
Into the 1800s.
Well, it says 1764, he discovered M40,
Hmm.
and the other numbers are right about, yeah, okay, so over the next few decades, perhaps, right?
Now, this is a Hubble picture of this M101.
Wow.
It is 21 million light years from Earth. And we're looking right down the road of it.
Mhm.
Looks like it's throwing its arms off into space.
Or winding them up. You can't tell with these things. You got to figure it out with with spectroscopy.
Hmm.
Okay, this one is does this one have a name?
106.
Intermediate spiral, that's what if it's M106,
Yeah, this is 106. This
just
is
an
Spiral
intermediate.
Nebula. It's got lots of hydrogen gas in it, all that red stuff.
Mhm.
Okay, but no name yet.
I don't think that there was a name for that.
We could call it the
And then-
Q-tip. The
What's that?
Q-tip galaxy. We could name it ourselves, the Q-tip galaxy.
Yeah. Now here's a cluster, nice little round thing of stars. Here's a nice little round cluster, another cluster, lot of clusters in here,
Yeah.
a lot of starbirth going on with this much gas.
Mhm.
Now, wait a minute, those are clusters in that galaxy or our galaxy?
No, that galaxy.
Yeah, it's
Oh,
not in
no
our
kidding.
galaxy.
Yeah.
Wow. Okay, and that's a spiral that we were looking at there? That's not a,
Yes.
Yeah, that's a spiral. We're looking at it at about 45 degrees or 50 degrees or something.
okay.
Generally, if you see a lot of dust, you're looking at a spiral, or in some cases, it's a spiral merging with an elliptical. But the ellipticals don't tend to have as much gas.
Are ellipticals turning?
I don't know what the collective motion of an elliptical is.
They're more
Okay.
like globular clusters where you just have random.
Okay. Here's the surfboard. Oh, Dad.
The surfboard galaxy with a little face-on spiral down here, little blurb there. There's another
little Beach
thing there,
Boys.
something there. This is much deeper in space.
the shape of a Muamua that came through. That was a rock.
We're not quite sure what the Oumuamua shape was. It might have been a pancake. It might have been a stretched out football.
Well, we're looking at a pancake here, though. Flat on, edge on.
NASA is still considering proposals to try and catch up to Oumuamua.
Really?
Yeah.
Like they can find it?
Oh, they know where it is.
Oh, they do.
They're tracking it. Yeah.
How about the Boranov or the Boris, the other one that followed? There was named after a Russian guy.
Borisov, yeah.
Borisov.
I don't know. That didn't generate as much interest as Oumuamua did from that point of view.
Well, there were some people thought it was an alien spaceship.
Yeah.
I'm not sure
Avi
they thought it.
Loeb.
You look at this guy that was an astronomer at what, Yale or Harvard it was, I think.
Yeah.
He said,
Avi Loeb.
what?
Avi Loeb.
Yes,
Avi
that's
Loeb.
right. He didn't say that's what he thought it was. He said it could be. He said
Okay.
it's not out of the realm of possibilities. He didn't say it's probable. He said it's possible.
Yeah, but
I
all
thought he
those,
did his prediction because it didn't follow, the laws of physics. It was moving around.
Yeah, it did move. It had acceleration to it, sideways, I guess, or speeding up.
Yeah.
But that could be to just the sun heating a pocket of volatile materials too.
Yeah, little jets.
But I guarantee you, whatever it did, it obeyed the laws of physics.
but it sure galvanized those people wearing the aluminum foil tin hats, didn't
That was just the latest thing at that time.
it? Back to the night sky we go.
Okay, now this was a challenge from Sky and Telescope. From the northern hemisphere, how much of the constellation of Centaurus can you see? And of course, we can't see much detail in faint fuzzies at this time because the moon is right up here next to my two favorite stars.
Mhm.
And so it's this, and this I think is, what did I set the planetarium software for?
Thursday
Oh,
night.
here. Whoops. 9 o'clock, January 7th. Yeah, tonight.
Mhm.
So the star you see is Theta Centauri, the northernmost of the constellation, also known as,
Menkent.
thanks. Oops. Menkent. Menkent. I always have to see the name because I never remember these names in detail. So this is about the maximum it's going to rise. You can see all these reference lines are peaked around this time. So around 9 o'clock, if you have a clear southern horizon, this is set for Galita's latitude. So I think that Tom Whittemore will have no problem
Yeah.
seeing this.
Yeah, I can see that.
Yeah.
Yep.
But my neighbor's house is right about
Those two favorite stars, what are they again? Your favorite?
Oh boy.
Oh,
Vega?
the claws.
Zubin El Janubi and Zubin Es Shamali.
Yeah, the claws.
Good. Good luck. I'm not going to get that one.
When I was a kid in elementary school and beginning junior high, we would go down every couple of months and see the planetarium show at Griffith Observatory.
Mhm.
And one time the speaker up there, by the way, they always played, to begin the show, they always played music by Debussy. It was my major introduction to really beautiful classical music. And but he said that one time someone had called him at the observatory, and they were about to have babies, he and his wife, and they found out they were having twin girls, and he wanted some stellar name. Could you recommend any
Oh no.
for the twin girls? And these are the two names he recommended.
Yep.
And I can hear that in my ears. I can hear him
That's
say,
crazy.
I
Yeah.
thought, what is
Yeah, Zubin is a claw.
Yeah.
Well, forgive me, but Debussy didn't do the planets. That was somebody else, wasn't it?
Holst. Gustav
Oh,
Holst.
Holtz, that's right. That's
Oh,
right.
yeah.
Well, so we're not up to
That's
Zeta
a, that's a,
Lyra.
it's a
Okay.
mouthful. It's almost like when Chuck was talking about what is it, the hydrocarbons with that word.
Polycyclic aromatic hydrocarbons.
Yeah, that's one I've never.
Okay, would this be the constellation Centaurus, part of your talking points, Jerry? Have we reached Zeta Lyrae yet in the
Yeah,
east?
this is it.
Oh, okay.
So up here, we have the Lyra, one of the easiest constellations to find. It's right near the Swan, the Goose, depending on how you look at it. And so this is right at between Chelyabinsk and Sulafat. There is a little break in that red line, and that's M57, the Ring Nebula. It's an easy, because of its location here and the position between these stars, it's an easy object to find. This is Delta Lyra, and this is Zeta Lyra. And this one out here on the end is the double double.
Huh.
Which is epsilon.
Yeah.
Is the Lyra part Lyrae? Does that make it plural or
That's
Possessive.
the possessive.
Yeah,
Yeah.
possessive.
possessive?
Right.
Oh, got it. Interesting. And then the waxing gibbous moon's going to eliminate everything in time.
Oh, there's a ton of stuff up there.
Scorpius, Antares, Delta Scorpii.
What are you talking about? What do you mean?
The next subject.
Oh,
That's
the
the
next
next thing.
subject. No, no, these are two sets of double stars up here. The double double and Zeta.
Oh, there's your double double. Okay. What does that mean? Double double?
Means
Two
quadruple.
binaries?
2 times 2.
So two binary systems are orbiting each other, or do they all four orbit somehow?
Ron, that double double is a test for our telescope's optics, and on a good night, you should be able to split the double double, and it's pretty hard. If you have good optics, you can do it.
Split as and seeing four stars,
Yeah.
and they're all. It's like a mini cluster or something.
No,
No.
it's two binary systems.
There's two stars that are brighter, but the other two are quite dim and very close. Very
But
close.
at 10 o'clock at night, it's well placed in the northeast. It's rising. This will be something that is more of a summer constellation and fall. It's getting in position now. It's near Hercules and near Cygnus.
Huh.
Okay.
There's Scorpius. There it is.
Yes.
That's big.
There's Scorpius, shows where the moon is. Today is the 17th right here. 18 tomorrow night. 19 on Wednesday night. 20, it's traveling down through Scorpius.
And we're nearing a major standstill, so it's really far south.
Yeah.
Well, is it approaching the two pinchers of the Scorpion, or in the middle there, the 19th?
Yeah, here's Scorpius. There's the two claws, one claw, the other claw. And here's the moon on, I guess it's Wednesday night or Thursday.
And Ron, those are the two reimagined claws, because Zubin el-Janubi and Zubin esh-Shamali mean southern and northern claws of the Scorpion. They used to be the claws.
Yeah, they used to go up here.
But we
That's because the Romans stuck in this constellation for the scales, because they saw Virgo as the goddess of justice, Astrea, and she needed scales. So they actually swiped part of the Scorpion and made this constellation Libra here.
Oh, interesting.
Yeah, Tim, a few nights ago, M4 was easy in binoculars, but not now.
Not with this, yeah.
But a week from now, it'll be
But somewhere else, the Crab Nebula also has claws, and it's represented, right, by stars.
No.
Claws of the there's
Crab Nebula is just a tiny supernova remnant.
Right.
Oh, you're
It's
kidding.
up in Taurus, Ron.
Well, I think he means the crab constellation, Cancer.
Oh, okay. Cancer the crab.
Yeah. The vermin of America, the vermin of our
Okay.
Time.
Time marches on.
Okay, here we
This
go.
was the common instrument, not too useful for astronomy, very vague-ish. Oh, darn it. I was gonna make a view graph of the different time zones that we need to have. So let me see if I can bring that up. Let's see.
24 is about right. Since we're
Yeah.
24,000 miles and 1,000 miles each at the equator.
And 24 hours to go around.
Yeah. But I'm sure there's other plans and other time limits or whatever they call it. Aha. It's going to be fascinating. We know what a solstice is, but can I just ask one quick question while you're doing this?
Yeah,
Is the distance between either of the cancers or either of the Tropic of Cancer or Tropic of Capricorn to your equator, is that the same distance in degrees as the Earth tilts? 23?
yeah.
Yes.
It is, okay. Then that'll be the
What defines them?
I'm sorry?
That's what defines those tropics.
Well, I know the farther north you go during our summer, the more hours of the day there are. But on the equator itself, they don't have 4 seasons. They sort of have 2, hot and a little hotter, don't they?
Rainy and not rainy.
Yeah,
Okay, but I'm wondering if at the equator where you would think it's 12 to 12, or no, 6 to 6, 6 a.m. it sun's up, 6 p.m. it goes down. That changes a little bit depending on the equinox or the solstice, right? In other words, they
In the
get
course of the year, it changes very little. Yeah.
but just you get a little extra during our summer months and a little less.
If you're north of the equator, yes.
Yeah, fascinating. Okay, Mr. President.
okay.
But if you're camped near the North Pole, the sun just goes around.
I know that's why you get more and
Been
more
there.
daytime. Yeah.
So we have moved from sundials to a more detailed this definition of time for different users and for different reasons. Plus, as you remember reading in last month's club newsletter, the moon is getting its own time zone.
Yeah.
So we're adding to that too. But these are the times that you're going to run into as an amateur astronomer. Local apparent time, local mean time, standard time, universal time, Greenwich Mean Time, ephemeris time, dynamical time, coordinated universal time, and sidereal time. But we only have 3 minutes to cover it, and it's fairly complicated.
Well, we could do it next week. Back in prehistoric times, they had their own daylight saving time, and they just adjust the sundial by 1 degree and turn it.
Actually, they turned the Earth. It was a lot easier.
Oh, that's well, I think
The
most of us,
railroads were the people that got time zones established because they needed to be at certain places in certain times.
Yeah.
but otherwise,
we got time zones in the US for the railroad.
Because of the trains. Yeah.
Yeah.
so is there going to be one time for the whole moon, or is it going to be divided
No,
up
it's
into?
going to be divided up into zones also.
You suppose the other countries?
It's going to come out different because the lunar day is different than our day.
But
Jerry,
28 days.
Well, if they're smart, they won't start doing it into multiple zones, I don't think. They'll just treat it as
Yeah.
hey, Jerry, when earlier I was going to ask about something maybe we could do in the future, and seeing this, it might have a part in it. Is that as we become more prolific in space travel, how do we are we going to navigate? What kind of a time time zones are we going to use? What kind of a grid are we going to work? Like in Star Trek, they used to have this Stardate something or other, and
You'll probably just refer it back to the Earth time if
Yeah.
they're coming from here.
I
Sure.
think
Okay.
But there are
Star
very
Trek-
precise clocks already out there in the form of pulsars, and so you could sort of do a pulsar time count that way.
how are we going to get a grid out there to
What do you
navigate.
mean a grid?
Well, like say if we have our latitude, longitude, and we're able to travel around the Earth using the GPS, but in space, what are we going to do?
That's where we'll use pulsars. Okay,
Oh.
because they're distributed around and they're like LORAN stations.
Okay. Gotcha.
When we sent one of the Voyagers out, it had a plaque on there that had lines drawn from the Earth to several pulsars, and it gave the frequency of the pulsar. So you could figure out where that was, and it gave the angles between these pulsars to get to Earth.
Huh.
Interesting.
Well, assuming the other countries that are trying to get to the moon right now, like Japan and China and India, you suppose if they're tuned in with what we have laid out grid-wise on the Earth, are they going to go along with NASA's plan for the time zones on the moon? Or do their own?
I think there will be an attempt to make it international.
Sure.
Yeah.
I don't know if everybody will cooperate.
Yeah, well, I think they will.
Well, this picture on the screen, keep it for future reference because I think it needs some explaining. 1 minute.
And this whole thing needs more explanation than we have time for.
Yeah.
Well, you did good anyway, gentlemen.
But this is the one that from Greenwich Mean Time to get to Pacific Standard Time, we're eight time zones away.
Mm-hmm.
So maybe we'll get into this in more detail later.
Oh, I'm looking forward to it. Ephemeris time, a dynamical time, coordinated universal time, sidereal time. My God.
Let's put it this way. I have a star chart, Norton's Star Atlas was the first atlas I ever got. And I got it in the late 50s. And it says on there, Epoch 1950.
Yeah.
And when I was working at Santa Barbara Research Center, working on space probes, we were working with Epoch J2000.
Right.
And the stars all shift because the Earth isn't really that well aligned to the stars, you might say.
Right.
And so it has to be corrected, and they tend to do it in 10-year increments.
Or
So
50-year, actually.
Yeah,
For
it needs to be 50.
Yeah.
okay.
Yeah,
And
you get all these words.
if you take a right ascension and declination off of an old star chart and put it into your new computerized telescope, you will not go to what you think you're going to go to.
And if you've got a small field of view, you actually have to, you might want to process to your current J date.
Yeah.
Right. That's right.
Yes. Epoch. What is the definition of epoch? Era, increments? My God, gentlemen. We've run out of time. We're going to do number 174 next week. Meantime, tell your friends about us. We do this every Monday morning. We're into our third year, actually fourth year, halfway through. Join the club now and come to our potluck in 3 Fridays. And I guess this weekend we'll be out at Westmont on Friday, and the next 2 Saturdays we're going to be out at El Cap.
El Cap 10 State Beach.
Okay, and the rest of you, take care of yourselves and your wives. You're looking good at your age, and doggone
Thank you.
Fascinating. Let's do it
And
again.
let me just also put in a commercial announcement. On next Sunday, I will be giving 2 talks at the museum at 1:30 and 2:30. The first one will be on infrared physics and the JWST, and the second one will be on black holes.
And you're going to be in Fleischman?
Drop by the conference room.
No, it's going to be in the gallery, right?
The gallery. Yeah.
Well, that's where we had the Dave Carey speech.
Yes.
Oh.
The Courtyard Gallery.
Yeah.
1:30 on Sunday. I'll be there.